Okay, so now let's start. So if I will not be able to answer your queries during this session, so we will have some time reserved for after this session so that we can take your query and we'll discuss on it. Meanwhile, you keep on posting your queries through chat. Okay, so today's session will mostly talk about like Linux kernel. Maybe you already aware about Linux kernel, what exactly Linux kernel is, but the whole idea of this first session is just to uh, bring up everybody on the same page so that whatever we are talking about during this complete training, it will be able, like it will be easily understandable for everybody. Okay, so the training agenda for today is like we will first understand what exactly Linux kernel is, who are the creator of Linux kernel, and who basically manage this complete Linux kernel. Okay, then we'll understand the different Linux version happens so far and how this Linux kernel version schemes basically works. And then we'll understand different Linux distributions which are basically based on Linux kernel and what exactly their relationships with the kernel. And then we'll move on and understand the Linux kernel patching process. So let's say if tomorrow you want to make some change into the any of the existing Linux kernel subsystem, or if you want to write a new driver which you want to mainline, so what is the process to follow for that? And then we'll talk about Linux kernel foundations, or the Linux foundation basically, which manage our Linux kernel. So we'll talk about it on that, and then we'll have a look onto the high level directory structure of Linux kernel, and then we'll talk about why Linux kernel is popular among other Unix type operating systems. Okay, so the very first thing is we have to understand what exactly the kernel is. So kernel basically serves as a core component of an operating system, which basically manages all your system resources, which facilitate the communication between hardware and software. So for example, an operating system or a machine which you have in front of you, maybe it's a Linux machine or Windows machine. Okay, so each machine basically gives you certain resources. For example, you have this machine in front of you. So this machine can expose you different services. For example, files, okay, memory, display, and other services which are running on the system. So now the thing is like you want to access all these services or the resources which are basically exposed by this machine. So we need a manager basically which can take control of all the services and which basically maintains how exactly we are going to access these resources. And also if we need, from user point of view, if we need something from this machine, we'll make a request to that particular part of system. So that system behaves like a privileged user for our operating system, or we can say the privileged component of our operating system basically, which manage all the requests which are coming in for maintaining all the resources or providing the services. So it basically facilitates the communication which is coming in to manage all the resources which your system is going to expose. So the kernel basically play an important role in each operating system basically. So operating system, when we say operating system comes up with the kernel as well as libraries as well as user level programs. So operating system is a group of all these layers actually. Out of all these old layers, kernel play very important role because kernel is such an important component which is going to take care of all the resources or the services which are available in your system. Okay, so you can see the roles here is, as I said, like it will manage your all the resources like your CPU, memory, input output devices, and also you have different processes running into your system. So it will manage all the processes because Linux kernel or any other kernel has to keep a record of like what all resources are available in the system and what all processes are currently running into the system. So all these information or bookkeeping thing is managed by our kernel, and kernel is of course responsible for the system stability, because let's say if you have some secret file in your system. let's say you have some secret file in your system and you don't want to give access to this file to everybody else which is accessing this system. So who will be taking care of that? Let's say user 1 is coming, user 2 is also there, user 3 is also there, and user 4 is the admin basically. Okay, so only admin can access this file, but user 1 is also trying to access this file, user 2 also trying to access this file, user 3 also trying to access this file. So who is going to restrict them to basically um log in, or maybe we can say the access to this particular file? So Linux kernel or any other kernel operating system, whatever you're using, so the kernel of that particular operating system has the bookkeeping notes where it has the information like which file a user can access and which file belongs to the admin, only admin has access to. So if we will not have kernel in place, so it will be very difficult for us to maintain the security of our system, because any process can come or any user can come and enter or access that file which we don't want to expose to everyone. So now I talked about kernel. So now let's switch to Linux kernel actually. What exactly Linux kernel is? Okay. So Linux kernel basically represent the core of Linux-based operating system. First of all, people generally say like Linux is an operating system. So do you also agree with that Linux is an operating system? Just type in the chat. Okay, Ajit said no, and Santil said yes. Kiran said yes. So just for your information, Linux is just a kernel project basically. So wherever we see this operating system coming in into the market like Ubuntu, and then Arch Linux, and then Gen 2, and all these operating systems are the distributions which is developed over the Linux kernel basically. Linux kernel is just a kernel project which is maintained by Linux kernel community, which we will discuss in the next slide actually. Okay, so Linux kernel doesn't maintain any of the user space process which is basically coming in. Linux kernel community only take care of the development which is happening inside the kernel. Okay, so you can see here this is just a simple diagram which just show you the general architecture of GNU based operating system. So you can see here like on the lower layer we have hardware platform, which is nothing but the all the hardware which is present in your system, maybe input devices, output devices, memory, and then other devices which can be connected to your system, maybe display, audio, and so devices basically. And then your Linux kernel comes into the picture, and Linux kernel has architecture dependent kernel code as well, which we'll discuss about later why it is there. Okay, so Linux kernel is basically maintaining all your hardware which is presented into the system. And on top of Linux kernel, you have system call interface in place. So this system call basically expose lot of system call to the user land. So here you can see in the user land, you have GNU-C library, and on top of GNU-C library, you have user applications running. So at point of time, if any user application wants to access some hardware, or let's say if you're writing a simple C program, you want to print that C program hello world or something you want to print on that console. So to print that program onto the console, you have to use the console device of your system. Okay, and your user space application will not be directly able to write that particular message onto the console. So there is a complete call stack which it has to follow to write a simple hello world onto the console. So what will happen is when user space application will write something or will try to access some hardware, so that user space application, let's say you're writing a simple C program, so that will lens down to GNU-C library, and from GNU-C library you will be invoking some system call. So system call will be coming down to the Linux kernel. So going ahead, we'll discuss all these system call, how system call happens and how this switching from user space to kernel space happens. But for now, you can just understand on the high level, like GNU-C library is invoking few system calls. So it will try to access the console device which we want to interact with. Okay, and then through system call, we will be entering into the kernel. Then kernel will make sure the device which we like wants to access from the user space, so that application has allowed to use. If yes, then kernel will allow them to access that particular device. So kernel play very much important role in any of the like the kernel Linux kernel distributions. Okay, so and also Linux kernel is an open source. So when I say open source, it means like anybody can access the source code of Linux kernel, and Linux kernel source code comes with the GNU license, in which if you are free to access the Linux kernel source code, but if you are making any changes into the Linux kernel, then you should mainline Linux that changes into the mainline Linux kernel, so that everybody else can take the benefit of that. Okay, which will avoid the reverse engineering, so that other don't have to spend time to fix the bugs which you have already fixed it actually. Okay. So now let's talk about like who invented Linux kernel. So Linux kernel was basically created by a Finnish American software engineer. So at that time in the 1991, he was working in the University of Helsinki. So at that time he was writing a academic project, a small academic project. Basically, he was writing just to perform some basic operations like TTY initializations and then network setups and all. He wanted it to do, but that project comes out so well that it handed over that project to the hackers, Linux hacker at that time, who basically participated well in this Linux kernel development. And from 1991, like this development is going on so fast. Now we have came across like multiple versions of Linux kernel. Okay, so before that, as I said, Linux kernel comes with an open source license basically. And now understand the purpose why Linus Torvald basically wanted to write a open source Linux kernel. So the thing is, at the era of 1991, there was the most famous operating system was Unix. So at that time, Unix was like very famous among all the engineers working on this platform actually. But the problem was with Unix, like if you want to make some change into the Unix, so you have to follow their licensing procedure. And again, sometime you will get that license or not. And also, even though if you will get the license, it will take a lot of time to mainline your changes, whatever you want to do. So this guy, Linus Torvald, was frustrated with that. So what he wanted to do, he wanted to develop an open source kernel, and mostly he wanted to work on the kernel side, and he wanted to develop an open source kernel which can be easily tested and can be compatible with any open source userland, so to avoid the dependency on the Unix based operating system. So what he did is he was only working onto the Linux kernel side. So he developed this layer, Linux kernel layer basically. Okay, so what he wanted is he wanted any of the user space userland basically, which can work with this Linux kernel actually. Okay, so at that time GNU was very famous. So GNU was working on their own operating system. So they also wanted to develop an operating system which is open source to to the world basically. So they were doing very good with the application side development, basically the development of Bash as well as GNU library, GNEC, everything they were developing very fine, but they were somewhere lacking for developing the kernel of their operating system. So at that time, Linus Torvalds a thought of it, why not it will be good if we can collaborate this Linux kernel with the GNU open source. Anyway, GNU is looking for some kernel for their operating system. So that is why initially this kernel was developed to test with the userland of GNU. And when we combine this interface userland with the kernel, so it gives you the GNU and Linux based operating system. So when you call like Linux is operating system, Linux individually is not an operating system. It is just a kernel basically. And to work it in a full-fledged manner, it needs a userland actually. And that userland can be from any of the vendor we'll talk about, like how exactly this happens. Okay, any questions so far? Okay. Okay, so as I said, like Linux kernel basically facilitate this communication between the user space and user space and the Linux kernel. Also, it manage all the memory resources, file system, device drivers, and everything. It manage to make your operating system works. Okay, so now let's talk about a brief history and evaluation of Linux kernel. But before going to that, let's first see basically. Okay, so there is a question from Ajit is Linux and Unix kernel are similar in architecture? So the thing here is like if you will see the kernel of Linux kernel basically. So Linux kernel was developed by Linus Torvald by taking the reference of Unix based kernel actually. So somewhere if you will see, you will feel some similarity, and Linus Torvald has their own things introduced in Linux kernel as well. So you cannot say like it's completely matching with the Unix based kernel, but somewhere you will see that architecture similarity will be there because he has taken reference from Unix Linux kernel while developing this Linux kernel actually. Okay. So, so as I said, like Linux kernel is an open source kernel basically which is maintained by a community. So this community is very large community, and this community is spread across the world. So around 14,000 to 15,000 maintainers all around the world are working to basically maintain your Linux kernel. And so this is the website kernel.org, which you can use to browse the different kernel versions actually. If you want latest kernel, so I will also tell you like how basically you can get latest kernel. Okay, so just to give you an idea like how we are going to perform our practicals. So the initial part of our training, we are going to perform our practical on the Linux machine. So it's better if you can have Linux machine handy with you. If not, I will suggest you if you can install some virtual machine where you can basically bring up some Ubuntu machine into that virtual machine. Okay. So the very first thing which you have to do today is you download one latest Linux kernel from kernel.org so that we can have a reference of whatever we are talking about in these trainings actually. Okay, so this kernel.org is the website basically which is maintained by Linux kernel community, and as I said, there are maintainer around the world participating in this kernel development. So if you will see these versions happening like very frequently, this 662 dot was released on 20th of November, and this 6.7 also in parallel released on 19th November, and before that 2011 we also have some patches for 652, and then 2011 the same day we have patches for long term Linux kernel. So first of all, let's understand what are the different version of Linux kernel basically. So if you see this word mainline, so what exactly this mainline means is, so mainline is the kernel on which this is the official release from latest official release from our Linux kernel. So what happens is, as I said, Linus Torvald basically is the creator of Linux kernel. So he owns all this Linux kernel development which is happening across the world basically. So what happens is like these maintainers are spread across the world. So if anybody wants to like submit some patches or something, so what they do is they create their own patch, they test it very well, okay, and they send that patch to Linus Torvald basically. So Linus Torvald will be receiving those patches, and he will keep some window open for some release to happen. So let's say for a release he's keeping a window open for 2 to 3 months. Okay, so he will be receiving patches from all the maintainers which are basically developing your Linux kernel. So they will submit patches to Linus Torvald, and Linus Torvald basically review those patches, and he can ask to basically make some changes as per his review comments. If he is okay to mainline those patches, so he will basically pick that patch and merge into the mainline kernel actually. But what happens is like people are submitting package these patches throughout these 2 3 months. So after 2 3 months, Linus Torvald will get bored and he will say, okay, that's all for this Linux kernel. Let's release it. So what he will do is he will release a mainline kernel. Okay, so this mainline will specify the latest kernel which is released into this Linux kernel community. So for now, you can see this 6.7-RC2. So this is basically RC2 if you see here, sorry, I spoke about stable kernel actually. Actually, the mainline kernel is the kernel on which the development is going on right now. So if you can see this RC2, which is means like it's a pre-release kernel on which currently the maintainers around the world are submitting their patches to Linus Torvalds basically. And once he's done with this 6.7 RC2 and he feels like we now can release this kernel into the market, or we can release this kernel. So at that time he will mark this mainline kernel as a stable kernel basically. Okay, and till the time this kernel didn't get stabilized, it will keep on updating actually. If you can see here, this RC2 is the second patch, so it you can have third, four, five, six, seven or so. Okay, so once he has finalized like this is the actual release going into the open source platform, so he will mark that kernel release as a stable. So as I said, stable release is the basically stable which is now nobody is basically updating that kernel, so it is already stable and released by the Linux kernel community. So if you are developing some product into the market, it is always advisable to pick any of the stable kernel from kernel.org. Okay, so there are various method of downloading this kernel actually. So what you can do is, if you want to download simply a tar file of Linux kernel, you can just click on here and you can download it. I have already downloaded it, so I will show you that kernel which I have downloaded it. So if you can see here, like this is the latest kernel which I downloaded today actually. This is the version 6.6.2, and after, so you will get a tar file actually. So if you will see this tar file size, that will be approx, you can see here is 100 MB or 140 MB or so. Okay, so once you have downloaded it, you need to like so you untar it by using tar utility or any other utility which you are comfortable with. So just give this Linux kernel tar file name. So it will untar this whole Linux kernel for you. And once this is done, when this uncompressing is done, you will be able to see the kernel here. And if you want to see the Linux kernel version of from the source code, what you can do is the simplest method is just go to the make file. And from this make file, you can see the version is 6, patch level is 6, and the sub level is 2. Okay, as I said, I have downloaded the Linux kernel version 6.6.2. So you can see here, this is the kernel I have downloaded it. And if you don't want to download this, so what else you can do is you can go here. Okay, so here you can see like version 6.x kernel, you can get it from here. So there all are the tar files. If you want to download it from any particular version of Linux kernel, you can also download it from here. Okay, and with that, if you want to download some like the latest, or I mean to say the historic version of Linux kernel, maybe the first Linux kernel version which Linus Torvald launches into the publicly, so you can get it here actually. If you can see here, this is the Linux hyphen 0.01 kernel actually, which he first written and released to the public. So here you can download the very first version of Linux kernel. Other than that, there is old version. So here also you have some older version like version 6.0.96. All these versions are maintained so far. You can download it and see like what was there in the initial version of Linux kernel actually. I will also show you, like I have also already downloaded. I will show you what exactly he has written at that time. Okay, so this was about kernel.org actually, and as I said, this Linux kernel.org will give you the latest release which is happened from the Linux kernel community. With that, there is a Git repository which is maintained by our Torvalds, Linus Torvald basically. So all the maintainers around the world submit their patches onto this repository actually, and Linux, and this Torvald will be reviewing those patches and will merge those patches into this repository actually. So you can see here, I will also send you the link if you want to see this repository. Okay, and from this repository you can get information for this Linux kernel actually. If you can see here, till now 814 tags is available for this Linux kernel. I will show you first how to download your Linux kernel repo. So if you want to download Linux kernel repo, you have to just clone with this particular link. So I have already done that in my machine. So you can see here, yeah. So if you can see here, like this is the Linux repo which I have already done. So if you will check the branch here, so this will give you the branch master. So if you can see here, this is the master branch which I'm currently showing to you. Okay, I was talking about tags. So each kernel version will have their own tag actually. You can see here, if you will give the command git tag, so it will list out all the tags which is available here. Hmm. So you can see there are list of tags which is available right now in this git repo. So this is the latest RC2 as I shown you here in the kernel.org. So this is the latest mainline kernel version on which the development is currently going on. Okay, so you can see the same version here, v6.7.rc2. Okay, so now let's say if you want to switch to some other version of Linux kernel, how you can do that? So what you have to do is, as I shown you, like you have different tags available here. So let's say if I want to switch to this particular, I will know this will be very old, but let's say if I want to switch to this particular tag, what you have to do is just check out. So let this checkout happen because this is very old version, so it will take some time to check out this older tag actually. Okay, meanwhile, let's see what else we can get from this GitHub repository. So if you can see here is like there are 14,718 80 contributor across the world, which is basically contributing for this development to happen. And with that, you can also see the list of maintainers here for different subsystem of Linux kernel. So if you want any information like which file is maintained by which particular maintainer, what you need to do is you need to search this file in this list. So if you can see here, this guy maintainer Johannes Berg, so he is maintaining these files actually. So these files are basically maintained by this particular guy. Okay, so we'll talk about like what we will use with this information in going ahead actually. So if you can see here, these file system files, the all file are maintained by this guy Eric Van. So he owns all this development which is happening across file system files. So he will be reviewing all the patches which are coming into the Linux kernel for this particular subsystem of Linux kernel. And then you have media driver, SSH driver, okay, then GPU driver. So you can go through this list if you want to. Okay, and most of our Linux kernel code is written in C language. So here you can see it is giving you the information like 98.3% of Linux kernel code is written in C language. Shell wise we're using 0.4%, Python also, Perl, Makefile assembly, and all these information are given on this website. Okay, so yeah, so now you can see that your checkout happened actually to this particular tag. So now if you will check the kernel version, so you can see here, this is the version 2, patch level 6, sub level 26. Okay, sorry, 16. So this is how basically you can maintain a Linux kernel repo locally into your machine. And for your information, like if you want to see what was there into this particular kernel version, you can see that part. Other than that, people generally ask like how exactly to get information, what get released into this particular version. So for that, actually, there is a website. The first method is you can read this change log actually, just to check like what exactly going on in this particular kernel version, but it will be very difficult from a user or the newbie to understand what is actually happening here. So the best part is like there is a website which we call is kernel new by. So if you open this website in the kernel new by, you can get a lot of information for Linux kernel actually. So it will gives you all the information related to all the kernel development happening across Linux kernel community. So better if you can have a look onto this website, it will give you a lot of information related to all the new versions and what exactly is coming in the latest kernel of your Linux kernel. Okay. Any questions so far? Am I making sense to all of you? Okay. Uh, Thanks. Okay, so now let's go ahead with the brief history and evolution of Linux kernel version. So as I said, like this Linux kernel was like developed by Linus Torvald in the 1991. So once he released the kernel, so that kernel version comes with this 0.01. And the time when he developed this Linux kernel, it like his intention was to write a simple project for his academics so that it can be used. And but later he realized this power of this Linux kernel, whatever he has written. So he which Ubuntu VMware on Windows host do you suggest? VirtualBox, QEMU, or hypervisor? As per your convenience, you can use any. I will suggest to go for VirtualBox. If you have, so in the later part of our training, basically we will be having some practical on Raspberry Pi board. So if you have a Raspberry Pi board handy, that's very good. If you don't have Raspberry Pi board, we will be using QEMU emulator. So that I will have one session on which I will guide you how you can set up your QEMU for Raspberry Pi board. Okay, but for have some initial sessions, I would suggest you to go with go with the Ubuntu VirtualBox. Okay, so as I said, like initially when he written this Linux kernel, it was very small actually. You can see here, I already downloaded this Linux kernel version 0.1. Maybe you can also download after this training. So as I mentioned, you can download this, like just to give you the information again, you can download, you can go to this HTTP path. Okay, from HTTP path, if you go to Linux, and then if you will go to this kernel folder, you will see this historic folder. And in historic folder, you can download this kernel from here and you can untar it in your local machine. I have done that. Okay, so this is the untar version of my Linux kernel actually. Sorry. Yeah. So if you see this this kernel actually, this kernel was so small and written very neat and clean. If you will go to the init file of main file of this Linux kernel, you will see very simple C file written here, and the total number of lines written into this file is only 147. So this is the init file which will be executed first time when your kernel will boots up actually. So in that simple main file, he's just writing a simple C program kind of writing actually. You can see the main function here. At that time, he was what he was doing only is like initializing the timer, initializing the console, trap initialization so that he can handle the traps and interrupt, then initializing the scheduler and then buffer management and then SD init for having the hardware and all maintaining. Okay, and then move to user mode to switch to the user mode if he wants to. Okay, so this was a very simple kernel version he launched into the open source community for the very first time, and then he asked hackers around the world to update this Linux kernel whatever the way they can contribute to. Okay, and now if you will see our Linux kernel, so right now this Linux kernel if you will calculate the Linux like lines, number of lines of code into this version, so it comes around 800 lines of code basically. But in the latest Linux kernel, I searched on the Google, it gives around 30 millions of lines is currently present into the Linux kernel. So Linux kernel has become now so bulky because the maintainers, as I said, like around 15,000 maintainers are already working for maintaining the Linux kernel. So they are keep on like updating Linux kernel with their own development which they are doing. So because of that, Linux kernel is getting bulkier day by day, but also it is adding on a lot more features, as well as they are working upon optimizations part for Linux kernel so that it can be optimized and perform better into the real devices. Okay, so now if I will show you the latest kernel version which I downloaded. So if you will go to the let's go to the main file first. Okay, and here you just see the number of lines. So these files also, at that time it was 143 line of code. It is now becomes around 1500 line of code. So 15 times the size of main file itself is increased. So you can assume that size of whole kernel get increased. And if you just check the size of this complete kernel, so it comes around 2.3 GB. But the size of that kernel Linux 0.01, it was around it was around 100 MB actually. So the size of Linux kernel, as I said, it's getting increased because lots of development is happening across Linux kernel. Okay. Okay. So now let's understand how exactly this Linux kernel development works. So as I said, like Linux kernel is basically open source. So if any of the company or any of the distro vendor wants to make some change into this Linux kernel, they are free to do that, but they comes under GNU license. So what does GNU license say is, like if you are making some changes into the Linux kernel and if you are releasing some product on top of that Linux kernel and you are giving it to the customer, so you cannot release that product only to the customer. What I mean to say is, let's say a company A comes into the market, they take the Linux kernel from kernel.org, okay, and they do some changes, okay, and they release that product to the market. They cannot create this binary and release into the market. As per the license, open source license or GNU license, they have to release the source code also. So this source code which they will give to the customer, or we can say the customer has right to get the source code of Linux kernel with the changes which they have done. So the source code which their customer will get, that will have Linux kernel as well as the changes which they have done during the development of their product basically. Okay. So and other benefit of this is like because people around the world are working on it. Now let's say this company A which was working on their product development, and they come to know there is a bug in the Linux kernel. Okay, so they will be making changes into this Linux kernel version actually, and now it is their responsibility. So the changes which they have done to fix that bug, they have to submit those changes to the respective maintainer of Linux kernel, and then maintainer will review their changes and he can update the changes as per his understanding, and then he will be doing the mainlining of the changes whatever they have done. So how it will benefit? So the thing is, now let's say at particular time thousands of companies are working on Linux kernel development basically. So now if only a single vendor has fixed the bugs, now these company who will be taking this latest kernel going forward, they don't need to face this issue again, and they don't need to make changes and spend time to fix the issue which is already fixed. Okay, so that is why Linux kernel community play a very important role in developing Linux kernel and making it stabilized and efficient for the product development in the market. Okay, so as I said, like because it's an open source in nature, so it encourages people to contribute and do the improvement and do the customization which they wants to, but they have to follow certain procedure to make their changes into the mainline Linux kernel. We will discuss about that, how this actually happens. And also, as I said, Linux kernel is managed through the Git version control. So as we have seen, this repository which trolls basically use, and we have downloaded it also, we have seen the different tags available. So this is the Git tool which is basically used to uh, maintain the different version of Linux kernel actually, and regular updates and enhancement by dedicated community. As I said, there is a community which basically works on this particular Linux kernel to update and optimize it. Okay, yes. So now let's talk about Linux kernel distributions. So at the initial part of this training, as I said, Linux kernel is a operating system or it's just a Linux kernel. So the thing is, Linux kernel is a simple Linux kernel project. Linux is a simple Linux kernel project basically, which is maintained by Linux kernel community. So to run this Linux kernel in any of the operating system, it has to have a user land associated with it so that it can gives you a complete operating system. So now what happen is, on top of Linux kernel in the market, we have different distro available into the market. You can see I have listed few here. You have Debian, you have SUSE Linux, Eld Linux, Ubuntu. All these are distros which are basically developed on top of your Linux kernel. So what happen is, as I said, Linux kernel is just a lower layer basically. Okay, and when Linus Torvald was writing this Linus kernel, so he was aware like he will only work on Linus kernel side, and also the Linus kernel community which we have just seen, Linus kernel foundation, so they just worry about this Linus kernel development which is happening across the world. So though they don't know anything about this user space actually. So they have developed Linus kernel in such a way any user land can come, and by making the very few changes, they can utilize this Linux kernel and give a complete operating system into the market. So all these distro vendor, which we have just seen you like Arc Linux, okay, then Gen 2, okay, Debian, Ubuntu, all these are distro vendor which is developed on top of Linux kernel. So on this Linux kernel, basically they will have their user land basically. Okay. So once you combine their user land with this Linux kernel, you will give an operating system to the market. So this is how your distro vendors basically develop their operating system on top of Linux kernel. Okay. And also, not only this distro vendors basically, now you know like it's a Android era. So all the mobile phones which are coming into the market, most of the if if they are using the Android, so Android stack also have Linux kernel on the lower layer. So you can see here, this is the Linux kernel, which is managing all the hardware present into your mobile display, camera, flash memory, Wi-Fi, power, audio, keypad, and all these informations or the devices are managed by Linux kernel. On top of Linux kernel, Android has their own stack. So they have their libraries, their framework, and then applications written in Java. Application framework they have written in C++, then their JNI interface, which converts their Java calls to your C++ framework. And then they have Android runtime libraries, which are part of this library layer. Okay, so Linux kernel play very important role even in the Android development basically. So that is why if you have good knowledge of Linux kernel, then basically you can get a job in all these company who is working into the Android based mobiles, as well as the company who is working or developing any of this distro vendor. Other than that, all the devices now presented into the market, most of the devices are now coming up with Linux kernel. Maybe they are using the light version of Linux kernel, but somehow you will feel somewhere they are connected with the Linux. Yeah. Now let's talk about submitting the patches to Linux kernel. So now let's say you are working in some organizations, or maybe you are an individual developer basically. You are working onto some product basically, and you realize that there is some optimization can be done into the Linux kernel, or you feel this is the bug in Linux kernel which you can fix it. So what you have to do is you will first identify that issue actually, and then you will make the improvement to fix that issue. Okay, then you will do the code modification as I said to fix that issue, and then you will create a patch. And before creating a patch, you have to validate whether that patch is really fixing the issue or not. If yes, then what you will do is you can submit your patch to the Linux kernel community, or you can talk to the maintainer for that particular file. For example, I have shown you in the Git repository actually. So there is a list of maintainers. So let's say, okay, let's say randomly, uh, you find a bug in this particular file, wmi.c. Okay, so here you can go and find who is the maintainer of this particular file. So you can see here this file is maintained by this guy Armin and Wolf. Okay, so what you can do is their email ID also mentioned here. Okay, you can send a mail to him and mention the file name, also submit the patch, and gives the information. This is the bug you found. Okay, and these are the changes which you have done to fix it and the way you have tested it. So he will basically review your patch. Okay, maybe he can ask you to do some optimization on in that patch. Also he can give you some suggestion to improve your patch actually, and then you will resubmit that patch. And then that patch will be, once he is okay with your patch, so what he will do is he will submit this patch to Linus Torvald. So Linus Torvald will finally review this patch, and he will review this patch, and if he feels this patch is good, because anyway this patch is already reviewed by Armin, so he has that credibility. Okay, so this patch is good. So most of the time he will merge that patch directly. Otherwise, he can also give his own comments on that patch, and he can ask to do some optimization as per his review comments. So there will be multiple cycle has to be followed if there is any review comments. So once that is done, everything is done, patch is finalized. So Linus Torvald will pick your patch in the latest release, which will be coming into the open source community. Okay, so here is the list you can find out. If you want to search some particular file here, just do Control F, you can find the list here. And with that also, there is a Linux kernel mailing list. Basically, I have already opened it somewhere. Okay. So this is lml lkml.org. This is the Linux maintainer kernel mailing list actually. Okay, so you can join this kernel list if you want to. I have also joined, but this will gives you a lot of mails, and actually, so I have just unregistered it. But if you want, you can join it. But you can read the latest message which is coming across all the Linux kernel community by going through all these patches actually, so you can understand what is actually going on in the latest kernel development. So this is the mailing list basically which they maintain to mail from one person to another person, and it is broadcasted into this channel so that everybody working for the Linux kernel development, they can be aware about it. Okay. So now sometime people ask, Linux Linus Torvald basically full-time work for this Linux kernel maintainer, and this Linux kernel is open source. So how does he get paid actually? So the thing here is this Linux kernel community is maintained by a Linux kernel foundation project actually. If you can see here is this is Linux Foundation project, so which basically maintain your Linux kernel, and the companies around the world which have their interest in Linux kernel, they sponsors and they pay to the maintainers as well as the Linus Torvald to work for Linux kernel. And first of all, Torvalds is like he doesn't work for money, because already he had a lot of money before writing Linux kernel itself. His father was already rich. Okay, so that's why he kept it open source actually. And the other reason of keeping it open source is like because he had he was a single person working on the Linux kernel. So he could have come up with the few ideas for improving the Linux kernel, but now he has all the people around the world who is working for them to optimize this kernel actually. So that is why Linux kernel is getting popular day by day. And it is nothing from today, it's just from last 1991, it's going into that pace actually. So you can see here the list of companies who are contributing to this Linux Foundation project actually. So these are the platinum members. So these are the companies which pay a lot of amount to for like for the development which is happening across Linux kernel, because these companies basically use Linux kernel so much into their product. You can take example Ericsson, Fujitsu, Hitachi, Qualcomm, Oracle, NEC, Samsung, Microsoft, Intel. All these are the platinum member, and then you have gold member, and you can see you have a lot of list here, thousands of companies who are basically sponsoring uh, the Linux kernel development. So it means these many companies have their interest into the Linux kernel development. So by going through this list, you can think of like these companies, because they are having interest into the Linux kernel, then of course they will have the jobs for the people who have the Linux kernel knowledge. So you can you can anyway see the companies who are working into it, and if you have any interest into their company, you can talk to them and go and work for it actually. Okay. Okay, let's have a 5 minutes break. We'll continue. So it's around 6, so we'll log in back. We can be on hold actually. We'll start again from 6:03. All right, let's resume. Okay, so we have discussed about like the guidelines and how to basically submit a patch if you want to submit to the Linux kernel community. Okay, and as I said, there are tools for patch submission. As I said, we have Git, which basically used for version control, and then we have the mailing list as well. Also, with the mailing list, we also have to maintain the documentation in the Linux kernel. So if you are fixing anything into the Linux kernel, or if you are making any changes into the Linux kernel, so it is always good to maintain the documentation for the same actually. So you can see here like maybe here I will show you, you have the documentation. So documentation is always good to read if you want to understand some particular subsystem of Linux kernel actually. So you have the documentation for everything here. So depending upon your interest, you can go through this documentation. So this documentation is very well maintained by Linux kernel community. So earlier, like with the initial releases, like before 2.6 kernel version, the documentation was not happening that much. But now Linux kernel community is focusing upon having documentation in place because people around the world are basically participating into the development of Linux kernel and they make changes according to their own understanding. And once that change get merged, then it's very hard to basically retrace that and to understand what was the changes done and why this particular variable of this particular structure is there actually. So for that, they are maintaining the documentation so that any new buy also can have look into that and understand. And also, let's say now tomorrow if you want to uh, be part of this Linux kernel community or the new buy when comes into the Linux kernel community, so most of the time they will ask them to work for documentation of some particular code or some files actually. So that the initial level they will be working on to documenting and improving the documentation of Linux kernel, and then going ahead once they have the competency and understanding of the whole procedure of maintaining and the Linux kernel, they start contributing into the Linux kernel code as well. Yeah, so this is about Linux Kernel Foundation, which we already talked about. So it's a non-profit organization dedicated to accelerate the growth of Linux and collaborative development projects. And lots of companies around the world are sponsoring that Linux kernel project. So the role of this Linux Foundation is, as I said, it's developing Linux kernel. Development of Linux kernel is happening around the world, so all this development cost a lot. So this cost is basically sponsored by the companies who are participating into Linux Foundation project. Okay, and also it encourages the people around the world to participate. Also, their engineers, the engineer who is working in these companies. Let's say we take example of AMD, Qualcomm, Nvidia, all these companies who are working on their devices. They also have dedicated engineer who is basically working to support mainline kernel changes. Okay, before that, huh. So now, as I said, like Linux kernel is most widely used. So like this is very old picture where you have this handheld device and the old mobile phones. But if you will see now, you have routers in your home. Okay, as well as you have mobile phones, gaming stations, and everything. So each of these devices nowadays are using Linux kernel as part of it. It may be a Linux version, it may be some other operating system written or some distro vendor written for your own particular device, or it may be an Android based mobile phones, but everywhere you will find Linux kernel taking part into it actually. So you will feel the contribution of Linux kernel in that devices. So you can see here even the servers, mainframes, and the supercomputer nowadays, also Apache server if you will talk about, so that also using Linux kernel as part of their a core component of the operating system. And then lot of operating embedded system which we are using in our day-to-day life, they are also based upon Linux kernel IoT device as well. And there are diversity of the devices which we are using. You can take example of mobile phones, smart devices, and other IoT devices which we are using, and then network devices. All these devices are basically using Linux kernel as part of their operating system basically. Okay, then let's talk about the importance and benefit. So first benefit is like stability and reliability. As I said, like So as I said, like Linux kernel community maintain this Linux kernel layer actually. Okay, so this Linux kernel layer is so much compatible with any user land. So now you take example of Arch Linux, you can take example of Debian, you can take example of Android. So all these distro vendors are using Linux kernel on the lower layer of their operating system basically. So Linux kernel is so much compatible with the user land actually, and it is open source. Other benefit of this is because it is open source. So because it is open source, you have seen like lot of development across the world is happening. So company don't need to. So the company who is only working onto the user space, or maybe who is working to develop this user land basically, they don't need to worry about optimizing Linux kernel, because Linux kernel optimization is already taken care by the community who is maintaining this Linux kernel. So they can freely spend their energy and the money on, or the time on the developing of or optimization of their user land. So that is the main benefit. This benefit is portability. Other than that, security. So Linux kernel is basically use virtual memory concept for maintaining their memory. So it provides you the sandbox for each process which is available into the system, so that one process cannot harm another process in the user space process basically. So it provides the security, and as I said, Linux kernel will be taking the responsibility, all the request which is coming from the user space, whether that user space process has like authority to access that particular resource or not. Okay, so this is how basically Linux kernel maintain the security of all the operating system. And the other thing is enterprisability. What does it mean? It means like, as I said, Linux kernel was first developed just to making it a compatible with the user land of GNU. Okay, but now if you will see, a lot of distro vendor has uh, comes into the picture, and now also, as I said, enterprise servers like Apache server, and then supercomputer, all they are using Linux kernel. So Linux kernel is such that much scalable, so it can be used in any of the larger subsystem or the larger device which is coming into the market. Okay, and also as I said, cost efficiency, because you don't need to spend money on maintaining Linux kernel, of course. So it will save you the cost as well as, and customizability ability anyway, as I said. And with that, Linux kernel is a modular basically. When I say modular, what does it means? It means like for Linux kernel, if you are writing some particular driver for, let's say for Ethernet driver, you're writing for, you have some Ethernet device which you want to launch into the market, and you're writing the driver for it, then you don't need to basically worry about other drivers available into the system. You can write your own module, and you can load it or unload it at the runtime basically. So Linux kernel provide that much modularity into the Linux kernel, so that it gives the benefit to the people who are basically developing their product on top of Linux kernel. So these are very few benefits. Other than that, there are a lot of benefit like cost efficiency. Already I spoke about security. Anyway, I have said stability as well as the reliability, because the good minds, or we can say the best minds around the world, is working to maintain Linux kernel. So you don't need to worry about anything for maintaining the Linux kernel. So that is also the extra advantage which people will get by using the Linux kernel based operating system into your devices. Okay, so what are the design goals of Linux kernel actually? So first goal, as I said, it's a performance optimizations, because a Linux kernel is now being utilized in embedded system devices, supercomputer, as well as the small devices like routers, and then other IoT devices basically. And these IoT devices, every time they have very much like very low CPU power, as well as very low memory devices basically. So to accommodate Linux kernel into their device, basically Linux has to optimize so that any low level device also can use Linux kernel as part of it basically. So there are a lot of optimizations usually happens throughout the year. So they are submitting the patches for like making that performance optimization of Linux kernel. And then, as I said, mentioned earlier, we have the portability across the platform. So you can see here is Linux kernel is being utilized in Android, Linux kernel is being utilized in Ubuntu, Linux kernel is being utilized in Arch Linux. So all these platforms are basically can easily use this Linux kernel as part of their operating system. A Linux kernel can be deployed in any of the hardware. You can deploy it on the ARM-based chipset. You can deploy it on the x86-based chipset, and you can deploy it with any other third-party vendors-based chipset also. So it has cross portability as well as flexibility. As I said, uh, Linux kernel community is always there. If you have some suggestion to optimize Linux kernel, if you have some suggestions to basically adding some new feature into the Linux kernel, so they are very flexible for that actually. Okay, but the thing here is, with having so much thing in place and with having so much people are working onto this Linux kernel, there are some drawback as well. So first drawback I will show you actually, because people are submitting their patches like anything into the Linux kernel. I will show you something here. Linux kernel had Linux kernel code has become so bulky, and also it's very difficult to understand its code sometime. So let's see if I see the latest Linux kernel code. So let me show you simple example. Include Linux. Yeah. So this is the include files basically, which basically manage your page structure. So this page structure we'll discuss about in the memory management section of Linux kernel. So this page structure is basically used to maintain the pages in your Linux kernel. Okay, so now you can assume like you have 4 GB of memory available into the Linux kernel, and one page size is basically 4K. Okay, so one page we use to maintain 4K of memory. So you can have millions of structure you have to have for this structure basically. So you have to have 1 million page structure, and if you see the size of structure, this is very large actually. So you can assume like just to maintain that 4 GB of memory, you should have per page. For that 1 million page, should have 1 million structure, which will consume a lot of memory. Also, now you will see this structure has a lot of unwanted thing also as part of it. And just see the type this structure is written. One second, just see this. It's a union struct, then again union. So you can see here in the union they have first written structure, and then again they have written union, and then structures, and then union. So these are the complexity. So being a newbie, if you will go and try to understand this code, this will be very difficult to understand. Even sometimes the maintainer who is maintaining this code, he is not able to understand, because once when these changes were merged into the Linux kernel, he was not there, and proper documentation was also not there. So it's very difficult for him to understand. Even sometime uh, they write also the same thing like these are the bugs, but we cannot fix it. I will tell you why they cannot fix it. Yeah, so you can see here, the maintainer himself is writing, actually this whole structure is a big mistake. It makes IO data with strictly high level data, and it has to know more about almost every data structure used in the inet module. So this is the net device structure basically, which we use in network devices actually, or the network device drivers actually. So you see the size of this structure, and also the data which is there in this structure. You can see the size of this structure. This is just an information which they are, or the documentation which they are maintaining to have information of this structure actually. See, yeah. So actual structure starts from here, and you will see the hell lot of content in this structure actually. So now the question comes, even though the maintainers are like aware about this messy code, why don't they update it? So the problem is like, because Linux kernel has gone into millions of devices, or maybe the billions of devices basically, so they don't want to break the code. Maybe they will remove something today, and now the vendor who are basically using their code, or this structure that comes into the picture, somehow he comes into the picture, then it will basically break their devices actually. So to avoid that kind of scenario, or to avoid that backward compatibility, like Linux kernel is bound to have these unused variables also in this Linux kernel, because they don't know who added these into, even though they have the patches and everything, but it's very difficult to track whole kernel now, because it is now, as I said, it's around 30 millions of code lines of code basically. it's very difficult for them to now optimize it, even though they are trying their best. But now the code is so much bulky, it will take a lot of time to optimize this code, this complete code actually. But the people are focusing towards optimization of this. So that is why when somebody comes to me and asks like, sir, we want to start understanding Linux kernel, shall we start understanding the Linux kernel code first? So I simply say no, you don't need to. First, read some theoretical part of Linux kernel, then you go through this code. Basically, this code is very difficult to understand, or it's better if you have some bare metal understanding of the of the devices, then you can start reading a simple module of Linux kernel. From there, you can understand, okay, so this is the documentation style of Linux kernel. Okay, now the questions comes why Linux kernel is so much popular actually. So as I mentioned, Linux kernel is open source, so it encourages the collaboration because the people from all over the world are contributing to the Linux kernel. So that is why the changes and development which is happening, so that is very much feasible or very much reliable for everybody, so that they don't need to spend a lot of time fixing all the issues which they come across in the Linux kernel, because there are a lot of people who are already working on it to fix it and optimize it. Okay, then as I said, it's reliable because every time a release from Linux kernel is happening, it has to go through their own procedure in which it has to be reviewed as well as tested. Then only it will be coming into the market. So that is why it is very reliable and stable. As well as security measure, as I said, uh, we have lot of bug fixes happening proactively around the world. So that is why Linux kernel is so much secure, even though they are working very hard to make it more and more secure day by day. And also, I said earlier, it's very customizable. You have the option to basically enable, disable some module. So now let's say you're writing a device, you are developing a device on which you don't need display. Let's say it's a network device and you don't need display. Then you don't need display driver as well, right? So you can disable all the modules which are related to display device. So this is how Linux kernel is very much customizable, also flexible. Now let's talk about high level directory structure of Linux kernel. So if you can see here is this is the Linux kernel which I have downloaded it. So it has on the top level so many folder, but we'll discuss about the main folder which we generally have interest for. Okay, so this arc folder will have the architecture specific code. So as I said, Linux kernel is compatible across different hardware. It is compatible for ARC86. It is compatible for uh, ARM64, ARM32, as well as other hardware which is present into the market. So this ARC folder will have architecture specific files or the code basically. You can see here you have ARM64, you have ARM, you have Alpha, IA, IOM68, Microblaze, Microblaze, MIPS, okay, Open Risk, PowerPC, S390. So all these are or x86. So now let's say if you are developing some new hardware architecture and also you also want to have the support in Linux kernel, so you can add your architecture specific code here. For the very first time, you have to make this Linux kernel compatible for you have to make this Linux kernel compatible for your device. So once this Linux kernel is ported, so let's say you download Linux kernel from your kernel.org, okay, and now you have written a new hardware architecture, let's say some XYZ, okay. So by default, when you will deploy that Linux kernel into that device, it will not work, right? Because you have to do your platform specific changes. You have to go through all the board sport procedure. You have to make this Linux kernel compatible with that particular hardware. And once that is done, so you will be doing some architecture specific to make this kernel compatible for that hardware architecture. Once that is done, you will be adding that change. If you want to basically mainline that change into the Linux kernel, you have to add that architecture specific code under this folder. Okay, this include will have all the header files, most of the header files, as I shown you this the net device header file as well as the page memory management header file basically. So it will have the lot of header file. In it will have the code which will be taking, or we can say the startup files which will be taking part once our kernel will boots up. So the code which will start first, that will be executing from this init directory actually. Then fs will have the code related to the file system actually. Okay, so drivers will have the drivers code for different devices available here. Kconfig will have the kernel configurations. Okay, maintainer, as I have shown you, like it contains the information related to the maintenance, but you don't need to have this directory info, at least for the development, if you are doing anything locally. Okay, and then there are script cells which you can use. Tools, there are a lot of tools, debugging tool as well as performance based tools actually, which you can look into. Okay, memory management subsystem has their code in memory management part. Okay, so these are the main directory basically which we use in Linux kernel. Okay, going ahead in this training we will be touching these directories so that you will have clear idea about what is actually there in these directory actually. Okay, now one thing I missed is how this distro vendor basically comes up. So if any of the distro vendor architecture you will see, so that will be similar to this structure which I am just drawing actually. So as I said, on the lower layer we have Linux kernel. Okay, so most of the time you will see most of these distro vendor will have this kind of structure actually. So this is their user land. Okay, so this is your hardware layer. Okay, hardware layer, then you have Linux kernel. Okay, then they have their library. So let's say if you're talking about GNU, so their glibc will be the library which will be interacting with Linux kernel by using a system call interface. Okay, and on top of GNU library they will have some other applications, or we can application library, or on top level they will have user space application written. So if you will have idea about any of this architecture like Arch Linux, Ubuntu, or Debian, if you will go and understand the architecture of these operating systems, so most of the time they will be maintaining their operating system in this way actually. So this is the underlying architecture, or we can say the layers involved in any Linux based operating system. And also the thing is, people generally ask why Linux kernel is so much popular, why not other free open source? Because FreeBSD is also uh, an operating system which open source. I will show you FreeBSD. Yes, I have open. So this is also FreeBSD project is also open source, and you can download the source code from here. But the problem with this FreeBSD is, if you have make any changes into their Linux into their kernel, and if you want to submit the change or optimization or the new feature changes which you want to submit into their mainline code, so you have to follow the very long procedure. So the first thing is, like in the Linux kernel, as I said, you can approach to the maintainer and you can submit their code. They will review it, and then if they find it good, so maybe within the span of 2-3 months, you will see your code is part of the mainline Linux kernel. But in case of FreeBSD, if you have something which you want to include into their mainline code, basically, what you have to do is you have to prepare first design, or we can say you have to write a paper for the changes which you are doing. Then this FreeBSD community will call you somewhere around the world. Some conference will be happening. They will call you and they will ask you to give the presentation for the changes which you are making. Okay, and if you will make the changes, sorry, you will make the design, you will make the paper, you will go and present the paper into that presentation. Then they will have judges, or from their community, which will judge you the design which you are coming across, the design is good or not. Okay, then they will take a call on that, and again, once they are ready, they will ask you to do the optimization on the design which you have presented into that seminar or the webinar actually. Once that is done, then you will start actually working on the changes. Then you will do the change, you will make some optimization, then again you will submit that changes to the to their internal community, which will again review the changes. Multiple cycle will happen. So this is how basically this changes submission works in case of FreeBSD. So you can understand it will take around 8 months, 9 months, or maybe a year to submit a change. So that is why they have very long cycle of publishing the changes if they want to publish into this FreeBSD. But in case of Linux kernel, it's very quick and rapid change, rapid development, and the rapid commercializations. I mean to say, in the rapid release was the main goal of Linux kernel actually. So because of that, Linux kernel is so much popular, and that is why if you see like any companies who is working into the developing the mobiles, so mobile have very short development cycle, maybe within 3 or 4 months, because market is now very competitive. Within 3 months and 4 months span of time, they want to release the changes, or we can say the release the device into the market. So they want something which give them the release very fast actually. So that is why Linux kernel is the first preference for the people who are developing devices on the on the system which require Linux kernel kind of kernel as part of their operating system. Okay, and also yeah, that's is done for all today actually. That's what I planned for today. So if you have any query, I'm just unmuting all of you so that you can ask if you have any questions. Let me know if you have any question.
Yes, I think not now.
Okay. Okay, so just to give you an idea is like after this training session, once you will log in back to this our platform which we are using for giving the training, so there you will see the recording there actually. Okay. Okay, send Ajit asked what is Rust folder. So the thing is they are going to use Rust programming in the Linux kernel. So Linus Torvald is also asking people to ramp up for developing their some subsystem into the Rust programming. So that is why you can find the code there in the Rust folder. But being a system developer, if you're working in any of the companies, till now it's not that much popular into the kernel-based devices actually. So it will be very rare for you to work on Rust actually in the Linux kernel. No, they can be profitable actually. As I said, they are allowed to use it, but the only thing is they have to definitely they can have consortium as well as there are non-profit organization as well as profitable organization as well. The only condition is if they are releasing some product into the market, they have to keep it open source. What are the changes you're doing they are doing into the Linux kernel? Senthil, you can buy any Raspberry Pi. Maybe it's 3, 4, or 5 also in the market. You can buy any of the Raspberry Pi board actually. See, frankly speaking, to understand Linux kernel first, you don't need any hardware device. If you have, it is very good. But other than that, you have Arch Linux as well as there are other distro vendor which you can easily deploy into any of the virtual machine actually. For initial understanding, that is good. But once you wants to have some project based on Linux kernel, then you should have some device handy with you or some hardware handy with you where you can utilize these skills actually. And also for the very basic initial development, you can use emulator as well. Like we have Kimu, which supports different architecture. It support ARM architecture as well as it. You can set up a Raspberry Pi emulator on Kimu, so that also you can use if purchasing a device is not feasible for you or you don't want to have the device. So that is also an option for you. As part of this Linux kernel training, we don't have session on boot procedure. In the Linux device driver training, we generally cover it because there we talk about like compiling the kernel and then booting up that kernel into the device. So there we cover that part. Also the device tree we cover there in that training. Yes, you will be getting this PDF in the same place in your dashboard where you will go to this course. You will be able to access this PDF there. So generally, going ahead, I will be presenting for 1.5 hour. Half an hour we'll keep it for any discussions to be happen, so that it will be a interactive session. My name is Shyam. Okay, any other question? If not, then I will close this meeting now. Let me know. Also, just give a feedback like it was meaningful for you to have this session today. Please give the feedback so that we can work on it if you need any improvement to be done in the coming sessions actually. Or yeah, lab sessions like we will be planning with the sessions like tomorrow we'll talk about mostly process management. Okay, so wherever it's required to have some labs, so we'll for the initial, as I said, for the training we'll be using this Ubuntu machines. But in the later stage of this training, where we will be going through one particular driver of Linux kernel, so there we will be using the Raspberry Pi. What about others? I have not heard from Hagar, Milan, as well as Suresh Kumar, Vivek Patil. If you guys have any question, feel free to ask. Okay, then thanks, Suresh. Thanks everybody for joining this class. For tomorrow, there is some plan of me. I will tell you whether the class will happen tomorrow or not, but I will confirm you over the chat actually. Yes, this recording will be available to you today after half an hour mostly. You can go in your dashboard and can get this recording there. You can go through that. Yeah, thanks, Milan. Okay, guys, thank you. See you in the next class. If you have any queries, just post your query in the community as we discussed. Maybe I will show you again just to keep you updated. So you can post your questions under your, you will have this community icon you will see in your dashboard. So there you can post your questions, whatever the question you have. Okay, thank you all. Thank you for the joining. Let's see you in the next class.